Can you believe that we used to poke people with needles rubbed on scabs? That was back in the 1700s, and thankfully we've figured out better ways to vaccinate. Vaccines have been the best tool in humanity's arsenal for fighting disease, and today mRNA vaccines are being looked at as a way to treat cancer. Vaccines work because we have adaptive immune cells that develop during the first encounter with the bad guy and stick around in case it comes back. They're ready the second time, so we have a stronger secondary adaptive immune response. It's adaptive because these immune cells adapt to hunt for a specific bad guy, almost like a bounty hunter. They know who's who thanks to antigen molecules, which work like name tags. Healthy cells have antigens that say, hey, I'm a part of you, and infected or foreign cells have antigens that say, I'm not a part of you. So immune cells know to attack. Some cells' whole job is just to show antigens to other immune cells to alert them. Vaccines can use dead versions of viruses, tiny pieces of viruses, or mRNA to present these antigens to your immune system. mRNA is preferable to the other methods for both safety and cost reasons. mRNA vaccines use messenger RNA to instruct our cells to produce an antigen by themselves, rather than having to introduce the actual virus into our system. So how can they treat cancer? Well, some cancer cells have special surface markers called neoantigens. They're special antigen name tags created by mutations in the DNA of cancer cells. Because they're only on cancer cells, they make a great target for cancer therapeutics, and the immune response won't target any healthy cells. To make a cancer vaccine, a surgeon removes the tumor, and a team of scientists take a really close look at the neoantigens on the outside of the cancer cells, and they choose some targets. They encode the recipe for those target neoantigens in mRNA, put the mRNAs in a protective envelope called a lipoplex, and put a bunch of those envelopes in the vaccine. When the vaccine is injected, the little envelopes travel into your cells in a process called transfection. The envelope breaks down inside of our cells, and the mRNA is translated to produce the neoantigen inside our own cells. Then, adaptive immune cells are produced that are specific to the neoantigens, and they'll target the cancer cells. These personalized mRNA vaccines have been found to be effective against pancreatic cancer in a clinical trial, where the vaccinated patients had more time without the cancer coming back, and some data even suggest that the new immune cells can attack secondary tumors forming in other parts of the body. Clinical trials for other cancers are ongoing, but vaccinology could be the next step in cancer prevention. Its success will depend not just on the science, but also on its PR. Because public trust of vaccines is at an all-time low, the only way to address that is open scientific dialogue.